Okay, here's warm-up 6R.1. How long would it take for $100 to triple if invested at 4% annual interest? So this annual interest piece is important because that tells us that we're compounding once per year. So n is going to be 1, in other words. So we just need the basic exponential growth formula for this one. You don't need the one with the n's in it because the n's will be 1 anyways. So I'm just going to use this one. Okay, A is going to be the initial amount, so that's the $100 we put in at the beginning. And then since it's tripling, the final amount would be 300. The y is the final amount. Okay, and then I've got 1 plus my rate. Now the rate is 4%, but we want to write that 4% as a decimal, so we'd want to move the decimal point 2 places to the left, and that would be 0.04 as a decimal. Okay, so when I do 1 plus 0.04, that'll be 1.04. Okay, and the thing I don't know yet is the time. That's what I'm trying to figure out. Okay, but there's my setup. All right, and now to solve this, I wanna start trying to isolate t as much as I can with old algebra techniques with the that I had before logs. So you can't put this into log form right now because there's nowhere for the 100 to go. Also, some people will multiply these together, but you don't want to do that because they have different exponents, right? You'd have to do the exponent before multiplying, and the exponent's unknown, so we can't really do that. But what we can do is divide the equation by 100. And now I've got 3 equals 1.04 to the t, okay? Now at this point, this is when I want to put this into log form. There's no way for me to isolate the t. I can't do it with square roots. That's not going to work out. I can't divide by 1.04. I see people try to do that too. Neither of those things are going to isolate the t. The only thing that's going to isolate an exponent like this is putting this in log form. So my base is 1.04. The exponent gets isolated, so that goes here, and there's only one spot left for the 3, okay? And now to put this into my calculator, I'm going to need to use change of base formula to change it into base 10. Some calculators you can use any base, but mine I'm going to have to do it like that, okay? So then I'm typing in log of 3. I'm going to close the parentheses before I divided by log of 1.04. It doesn't really matter if you close the second parentheses on bottom, but you definitely have to close before you do the division. Okay, and then I've got about 28.01. It says round to the nearest hundredth of a year. So it's that many years, roughly. Okay. All right, let's try another. How long would it take for $100 to triple again? But this time we're compounding continuously. So that means on this one, we're going to do an infinite amount of compounds. We're continuously adding the 12% back in. All right, and then so we need this formula, the one with the E when we're doing continuous compound. All right, so A is my initial amount. That's going to be 100 again, and my final amount's going to be 300 since it's tripling. E is just a number like pi. It's, you can see the value of it in your calculator. It's stored in there if you have a scientific calculator. It's about 2.718. All right, my rate here is 12%, but again, I want that as a decimal, so 0.12. And the thing I don't know is t. So yeah, there's two variables, but I know the value of e already. I just don't know the value of t. So that's what I'm looking for. So just like on my previous problem, the first thing I want to do is divide by 100. Don't put this into log form yet because it's not 100e raised to that exponent. It's just the e being raised to the 0.12t. 100 is really raised to the first, right? You could put a little 1 up there, okay? So trying to isolate the t, we can do a little bit of that by dividing first. And now we're going to put this into log form, okay? So in log form, my base is e. The exponent is going to get isolated, so that's the 0.12t, and then the 3 is going to go here. And when we've got a log with a base of e, that's our natural log. So that should be, natural logs are also programmed into any scientific calculator. So that means we don't have to use change of base. You could do log of 3 over log of e, but I can just use this ln button, right? So ln, here, let me clear this out. Natural log of 3 is going to be about 1.986, 1.0986. And then I'm going to divide by 0.12. Okay, so I'm going to use this whole decimal, even though I didn't write the whole thing down. I'm going to divide that by 0.12. It's good to try not to round as you go. So then now I'm going to round my answer. So the time then would be about 9.16 if I'm going to the nearest hundredth. It's that many years. Okay. All right. So these next two, this next one we're solving for x. So when I have two different logs with the same base, I'm going to want to combine them. But before we combine these, we have to deal with the 2 and the 3 because you can't combine logs that have coefficients. But what I can do is use the power rule. So I'm going to take the 2 and place it as an exponent of the x, and the 3 will become an exponent up here. So this would be equivalent to the natural log of x to the second plus the natural log of 4 to the third. My pen's dying there. I'm going to switch to my red pen. Okay, so now I can combine these because they have the same base and they don't have coefficients. So 4 to the third is going to be 64. So let me just do that first. Okay, so now when you're adding two logs with the same base, these both have the same base, you're going to multiply the contents, the arguments together. So this is going to be the natural log of 64x squared, and that's going to equal 8. Okay? All right. So we're trying to solve, now that we've got those two logs combined, we're trying to solve for x here. So I want to get the x isolated, and that means I've got to get it out of this log. And the only way to get it out of this log is to rewrite my equation in exponential form. And you don't have to write log base e, but you got to remember that's what this means, because now when I convert this, it's going to be e to the 8th equals 64x squared. Okay. So now trying to isolate for x. Don't take the square root yet. You could actually take the square root, but you got to take the square root of the 64 as well, the whole equation. So what I'm going to do instead is first divide by 64. So this is going to be e to the 8th over 64 equals x squared. Okay. And now I'll take the square root of both sides. Okay. So typically we would have a positive and a negative root when we take the square root of both sides of the equation. So usually we'd have a plus minus in front of this. Okay. But then I also need to think, well, if I had the negative version, it's going to be negative some decimal, right? Well, I can't have the contents of a log be negative, so that would the negative one would actually be extraneous. So I'm only going to use the positive root in this case. Okay. And so this is an exact answer. You could split it into top and bottom, so you could write it as square root of e to the 8th over 8, right? Because the square root of 64 is 8. But I'm going to use a decimal anyway. So let's see. E to the 8th is this. Let's divide that by 64. Okay, and then I'm going to take the square root of that number. And you can use the last answer button. But if you don't know how to do that, use as much of the decimal as you can. So that's about 6.82 then. Okay, all right, last one. We're going to find the inverse then of this, this function. So I want to switch the x and the y. That's my first step, always finding the inverse of an equation. And then I want to isolate the y. I'm just treating the f of x like a y for now. Okay. All right, so I'm trying to get the y isolated. Well, I can start by subtracting 5 from both sides of the equation. So now I've got x minus 5 equals e to the 3y, okay? Now I'm going to try to isolate the y. I got to get the y out of the exponent. Only way to do that is by putting this into log form. So my base is e, the exponent is going to get isolated, and then the contents is going to be the quantity x minus 5. So if you just write it like this, it's not really clear if the negative 5 is supposed to be inside the log or not. So when you have multiple terms, I think it's a good practice to put them in parentheses to show what's inside of the log and what's not, okay? And that's my natural log, right? Okay, and now we've almost got y isolated. I'm just going to divide by 3. Okay, and there's the inverse. And the last thing is I'm just going to put this in an exponential form. Not exponential form, in a function notation, sorry. So instead of writing y equals all that, I'm going to say I'm going to say the inverse of f of x equals all that. Okay, and that is the end of the warm-up, and I'll see you next time.